So today we are going to discuss alkenes. So as you know, student, alkenes have the general formula CnH2n. They contain
Yes.
2 hydrogen less than alkane. They contain 2 hydrogen less than alkane. The first member, that is CH2, is unstable.
sp2 hybridization.
This is called methylene or methylene. This is unstable. So we will discuss from 2, n equal to 2. So it is C2H4. We call it ethylene. Common name is ethylene. Ubiquic name is ethene. So the structure is like this. So this is sp2 hybridized trigonal planar, and 120 degrees bond angle. So this bond angle is almost 120 degrees.
Noted, sir.
Good. So they are unsaturated hydrocarbons. They are unsaturated hydrocarbons. And they have at least one double bond in their structure. So they contains 2 hydrogen less than alkane. The general formula of alkane is CnH2n plus 2. CH2 is unstable, that we call it methylene or methene. N is equal to 2, it is C2H4, it is called ethylene, common name is ethylene, and ubiquic name is ethene. Ethene is the ubiquic name. So keep this in mind, ethene is the ubiquic name. Now keep this in mind that ethylene is also a plant hormone. It is also a plant hormone, and it is a fruit ripening agent. So these two things you keep in mind. So it is a phytohormone,
Yes,
plant hormone, and it is also a fruit ripening agent. The carbon-carbon double bond is 1.34 angstrom in length. Keep this in mind. And the strength of this double bond is 681 kilojoule per mole. Note down.
noted, sir.
No problem?
No problems.
Good. Now, we will discuss the nomenclature. So how we will write? Suppose it is CH2 double bond CH2. Simply we will write ethene. Suppose it is CH3 CH double bond CH2. So it has one double bond and 3 carbons. So it is called propene. But from butene onwards, we have to make sure that we mention the position of the double bond also. So it is called butene. And this is called but1ene. Keep in mind that but2ene and but1ene are position isomers. But2ene do show geometrical isomerism. But1ene will not show geometrical isomerism. Show geometrical isomerism, I will explain later part of the video. And but1ene will not show geometrical isomerism. So the name of this compound is, you have to give priority to the double bond. So 1, 2, 3.
It is
4.
butane. Butane.
3 methyl
Methyl butene.
But 1-ene. So write down. Next question is like this. What will be the name? So you just have to first number it and then you have to solve. So 1, 2, 3, 4, 5, 6, 7, 8. So it is octane actually, octane derivative. So we can write octa 1, 3, 5, 7 tetraene. That means it has 4 double bonds. So it is called octa 1357 tetraene.
Noted, sir.
Next, CH3 hold to CH, CH double bond, CH, CH2, CH double bond, CH, CH, CH3. Here is CH, C2H5. So this you can try yourself, students. So you have to here substitute this. So CH, one is methyl like this. Here is one methyl. CH double bond CH, CH2 single bond double bond, CH double bond CH, CH, CH3, CH2, CH3. So ethyl can be written as CH2, CH3. So now you have to find out the longest carbon chain, making sure that the substituent and double bond gets lowest numbering. So from this side, we are seeing that 1, 2, 1, 2, 3, 4. Double bond is fourth position. Here 1, 2, 3, third position. So we have to write from this side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 8 position is methyl, 2 position is methyl. So 2, 8 dimethyl. 2, 8 dimethyl. Now we will see that it is decane. So it is deca 3 deca 3 6 3 is a double bond, 6 is a deca 3 6 diene. So this is the UPAC name, student.
Yes, sir. Sir, I have a doubt here, sir. Why did we write dimethyl deca 3 and again 6 diene here, sir? Like 3, like here again 8 is also a bigger number than 6, no, sir. Again it's 20 here.
3 number position is a double bond and 6 number position is a double bond.
Yes, sir.
So both position has to be written for why we are writing. Di means 2, in means double bond. So we have to write why we are writing C6. Okay.
Okay, sir. Noted, sir.
Now one question is count total sigma and pi bonds in. First question is ethene C2H4. Second question is C2CN whole 4. This question has been asked in IIT. So try. Now, for your kind information, students, cyanide has triple bond. So you have to write that cyanide has triple bond. So every cyanide you put it triple bond, then you will understand better how to count sigma and pi. Triple bond, triple bond, triple bond, triple bond. So now its counting will be pi. A triple bond is 2 pi 1 sigma, 2 pi 1 sigma, 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 pi, sigma, sigma, 2 pi here.
Then again sigma,
sigma, sigma, 2 pi. So total, if you count here, then here is 1 pi and 1, 2, 3, 4, 5, 5 sigma. Here is 9 pi, 9 sigma. So this question has been asked in IIT and also at some other entrance exam.
yes, sir.
Now isomerism in alkenes. So mostly alkenes, so structural isomerism. And in structural isomerism, alkenes show chain and position isomers. Chain and position isomers. Like so butane and 2-methyl propene, these are chain, but butane and butene, these are position. Other than this, they also show one of the most important type of isomerism under configuration, that is called geometrical isomerism. So most of the entrance exam as well as board exam do ask question from geometrical isomerism. So this you have to prepare.
Noted.
Now let's discuss geometrical isomerism. So you have to know that there is a restricted rotation around carbon-carbon double bond. Due to presence of pi bond, there is a restricted rotation which give rise to geometrical isomerism. Now, first condition is carbon-carbon double bond, carbon double bond nitrogen or nitrogen-nitrogen double bond must be present. Second, in carbon-carbon double bond, one carbon must be attached to two different groups. It should not be same. Suppose if you have like this, two same group, then it will not show geometrical isomerism. It will not show, but it will show. So keep this in mind. So if the groups are on the same side, then it is called cis. If the groups are on the opposite side, then they are called trans. So I will give you a beautiful trick of cis and trans. So if the groups are on the same side, then it is called cis form. And if the groups are of opposite side, then it is called trans. So let me give you a few examples. Now these two compounds you see properly. This is cis. It is called cis dichloroethene. So you can write cis 1,2-dichloroethene. That will be more better because two chlorines are attached to two different carbons. So cis 1,2-dichloroethene. The trans form of this is HCl ClH. So this is called trans 1,2-dichloroethene. So this is called the cis trans isomerism. In cis, the groups are on the same side. In trans, the groups are on the opposite side. So note down.
Noted, sir.
This compound, this is called 1,1-dibromoethene. It will not show because the groups are same. So no geometrical isomerism. Note down. So it will not show any geometrical isomerism. Will this compound show geometrical isomerism?
Yes, this is a cis alkene.
Cis, yes. So it is, its name is 1, 2, 3, 4. So it is 2-chlorobutene. 2-chloro. So it will be cis 2-chlorobutene. So it will show geometrical isomerism and it is cis form. Sometimes what happens, we cannot locate cis and trans, like in this molecule. It is cis or trans, we cannot say because all the groups are different. So here we take the help of EZ nomenclature. Here we take the help of EZ nomenclature, Intgegen and Jusemen. Intgegen means opposite, Jusemen mean together. Now this priority are set by CIP rules. Can, Ingold, Prelog rules. So first, in case of the group attached, we see the atomic number. The group which has more atomic number is given more priority. In case of isotope, we see the mass number. So deuterium mass is more. So this is on the same side. So it is called Z form. So where cis trans fails, we take the help of int gegen and Juiceman. Int gegen is opposite and Juiceman means together. So when the groups are together, like these groups are same side, so Z form. Understood?
Yes, sir.
So in case of any element, we see the atomic number, but in case of isotope, we see mass number, because isotopes have same atomic number. Now I'm giving you one trick. This will be really a very, very important trick for you all. The cis trans trick. Dipole moment, boiling point, melting point, and stability. So dipole moment, cis has more dipole moment, so it is high. Boiling point also it has high. Trans has low, so low, low. Now melting point of cis is low, so low, low. So write down. So cis has high dipole moment, high boiling point, but low melting point and low stability because cis is highly reactive. Trans have low dipole moment, low boiling point, but it fixed in the crystal very well firmly. So its melting point is high. Stability is also high. So you will remember the trick: high, high, low, 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 high, high. High, high, low, 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 high, high. But don't forget the sequence: dipole moment, boiling point, melting point, stability. Otherwise, it will become ha ha hoo hoo. Understood?
Yes.
So cis has more dipole moment. That means it's dipole. This is dipole moment. So dipole moment is a vector quantity. It is the product of charge into bond length. Product of charge into bond length. Its unit is debye. 1 debye is equal to 3.33 into 10 to the power minus 30 coulomb meter. Coulomb is the SI unit of charge and meter is the SI unit of length. So bond length. So charge into bond length. If the dipole moment of the molecule is 0, then it is called non-polar. And if the dipole moment of the molecule is not equal to 0, then it is called polar. So in case of cis, the dipole moment is high, its boiling point is high. But in case of trans, the dipole moment is low and boiling point is low. So high, high, low, 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 high, high. Remember this. This is a beautiful trick. This will help you solve 8 questions. Can you tell this is cis or trans?
This is not either of them.
So you can write each, it will not show no geometrical isomerism because the same groups are attached to one carbon. Okay. So this question, this will not show any. Next, CH2 double bond CBr2, can it will show geometrical isomerism? It will not show
No,
because
so there are no conflict.
yeah, so it will not show. It will not show because the groups are same here. So it will not, no GI. This is phenyl group. So is it cis or trans?
This is cis.
Yeah. So this will show geometrical isomerism. What will be rated, cis trans or EZ? What is the name for this?
This is not cis and trans.
This is easier. You have to tell. How you will tell? First, atomic number. So fluorine, chlorine is more. Bromine, iodine,
Yes, sir.
iodine is more. So it is called
Iodine
Z.
is more.
It is called Z form. Juicemen means
Z.
together. Juicemen means together.
Z form.
Now, methods of preparation of alkenes. So first method is from alkynes. You take a alkyne, treat it with hydrogen in presence of palladized charcoal. So in presence of palladized charcoal, this partially deactivated palladized charcoal is known as Lindlar's catalyst. What we call it?
Lindlar's catalyst.
Lindlar's catalyst. So it will form cis alkene. Cis alkene means similar group will be on the same side. Okay, so this is cis alkene. Very important question. In case of Lindlar catalyst, cis alkene is formed. Next, you take alkyne, treat it with hydrogen, but you treat it with sodium in liquid ammonia. It will form trans alkene. It will form trans alkene with groups are on the opposite side, same side. Okay, so this is called trans alkene. Very important in case of Lindlar catalyst, cis. So Lindlar catalyst, cis, LCC. In case of sodium liquid ammonia, Birch reduction trans, BRT. So it is Birch reduction. So it is BRT, Birch reduction trans Lindlar catalysis. This is the trick to remember. When you take propine, treating with hydrogen in presence of palladized charcoal, Lindlar catalyst, there is nothing called cis trans over here because propene will not sort cis trans isomerism. So just where propine gets converted to propene in presence of palladized charcoal. So there is no question of cis trans because propene will not show cis trans.
So only cis and trans can only be shown by only by alkene.
Alkene with different group attached to carbon.
Yes,
and
sir.
it will be shown by some carbon double bond nitrogen group and nitrogen double group. I will discuss this also in IIT lecture. Okay.
Yes, sir.
Second method is from alkyl halides. So take a alkyl halide, which have a beta hydrogen. So halide group attached carbon is called alpha, and just beside alpha carbon is beta. So it will be treated with alcoholic KOH. So heated. So what will happen? This OH minus will abstract a beta hydrogen. So OH minus will abstract a beta hydrogen. So this will be given. This halide will come out. So it will form alkene. Now this will become, so from alkyl halide it becomes alkene. So it will form ethene. So it is one haloethane. So one haloethane, it can be one chloroethane, one bromoethane. It will be converted to ethene. I hope you understood.
Yes, sir.
So here removing iodine is very easy because iodine is a very good living group. Great. So in case of iodine, it will be more than bromine, then chlorine. Now keep in mind that from tertiary group, it will be easily removed, then secondary, then primary. And this reaction is called beta elimination. This reaction is called beta elimination because the hydrogen is eliminated from the beta carbon. Beta carbon is a carbon which is next to the alpha carbon. So this is alpha carbon where X is attached, this is the beta carbon. So this is also called beta elimination. Next method is from vicinal dihalides. From vicinal dihalides. So you take 1,2-dibromoethane treated with zinc. Zinc will take away both the bromine, so it will form ethene plus ZnBr2. Since the halides have been removed, so this is an example of dehalogenation. Removal of halogen is called dehalogenation. D means removal, De. Since here halogen and hydrogen both has been removed, so this is also called dehydrohalogenation. Dehydrohalogenation. Removal of HX. Removal of HX.
HX. The alkyl halide.
Yeah, removal of halogen, so dehalogenation. Next reaction is from alcohols by acidic dehydration. By acidic dehydration. So when alcohols are treated with dehydrating agent like H3PO4, H2SO4, then it undergoes dehydration to form alkenes. So what happens? This reaction, what happens? The proton coming from acid actually is protonated by this oxygen. So it forms protonated alcohol. The protonated alcohol has a plus charge on oxygen, so it becomes a better leaving group. So it forms a carbocation. This carbocation wants to get stabilized, so the proton gives the electron and it forms alkene. This is the reaction happens.
Sir, can you repeat this, sir?
This oxygen lone pair attacks this H plus. Okay, because OH is not a very good leaving group. OH is not a leaving group, but OH2 plus, this is very good leaving group. It leaves so that it becomes water, creating a carbocation. This is carbocation having a carbon with positive charge. So this is a carbocation. Now this carbocation pulls the electron from this carbon asks the proton to give electron and go away. So this reaction removes the H plus, that means H plus over here acid, it is acid which is acting as catalyst. Understood?
Yes, sir.
Suppose you are given this alcohol and you are asked to treat it with Conc H2SO4. Then you will get this type of compound. Why? See, so this will react to form OH2 plus. This will lose one water molecule to form a carbocation. It's not benzene, it's cyclohexane derivative. Now this will lose one water molecule to form a carbocation over here. Now here is hydrogen. This hydrogen will give the electron, so it will form. Double bond will be formed here, and proton will be eliminated. This proton only actually started the reaction. This proton coming from the acid. So cyclohexanol will form cyclohexene. Understood?
Yes, sir.
Now we are going to discuss physical properties of alkenes. So write down. First three members are gases. Next 14 members are liquids. Higher members, above 14, 15, they are solids. So as the mass increases, molar mass, substance convert from gas to gas to liquid to gas solid. Ethene is
Yes, sir.
a colorless gas with faint sweet smell, with very little sweet smell. Alkenes are insoluble in water, so they will not dissolve in water, but are fairly soluble in organic solvents, or you can say non-polar solvent, like benzene, petroleum, ether, etc. So they are soluble in non-polar solvent or organic solvent, but they are insoluble in water. They follow this principle, like dissolves like. Like dissolves like. So polar solute dissolve in polar solvent, non-polar solute dissolve in non-polar solvent. They show regular increase in boiling point with increase in size. That is, every CH2 group added increases boiling point by 20 to 30 Kelvin. Note down. So they show regular increase in boiling point with increase in size. So as the size of the molecule increases with every methylene group, that is 14 AMU, the boiling point increases by 20 to 30 Kelvin.
So then the higher number of alkenes will have the highest boiling point then.
Yeah. And keep in mind that branched alkenes will have lower boiling point as compared to their straight chain counterparts. So branched alkenes, in case of isomeric alkenes, do keep this in mind, have less boiling point than unbranched alkenes. So branching decreases the boiling point. Branching increases, surface area decreases, van der Waals force decreases, boiling point decreases. So as branching increases, keep this in mind. This is very helpful.
Increase surface area.
As branching increases, surface area decreases. Van der Waals force decreases, boiling point decreases. So this you keep in mind. This is very helpful. Now we are going to see chemical properties of alkenes. Chemical properties of alkenes. So first is addition of hydrogen. So as you have read in previous class also alkanes, that alkene react with hydrogen in presence of nickel, palladium, platinum. It forms alkane. Keep in mind that with nickel it is heated. With nickel it is heated, but with palladium, platinum the reaction occurs at room temperature. So if you have, and if the reaction with nickel is also called Sabatier-Sandrens reaction. So ethene reacts with hydrogen in presence of nikah pade pande. Nikah pade pande. That is the trick. Addition of halogens. Addition of halogens. So ethene react with bromine in presence of CCl4 to form 1,2-dibromoethane. This reaction is the test of unsaturation, because this reaction actually discharges the color of bromine. So colorless solution it forms. Reddish orange color is discharged. Reddish orange color, it becomes colorless. It becomes colorless. So this is the test of unsaturation. When there is a color that gets discharged, so this we confirm that the molecule has multiple bonds. Propene similarly will react with chlorine to form 1,2-dichloropropane. 1,2-dichloropropane. These are example of electrophilic addition reaction. These are example of electrophilic addition reaction. Copied?
Copied, sir.
Next is addition of HX, hydrogen halide. Addition of HX. So when alkene is treated with HX, what happens? This pi bond shifts to proton, this bond shift here. So it forms this double bond breaks. So this is attached and it becomes a carbocation. Next step, what happens? This X attacks over here and it forms a hydrogen halide. Means so haloalkane is formed. Now keep in mind that in symmetrical there is no problem. One double bond breaks, one atom plus charge carbon gets halide, and negative charge carbon gets hydrogen. But in case of unsymmetrical alkenes, the addition of hydrogen halide, that is unsymmetrical reagent, obeys Markovnikov's rule. That is very, very important, students. So take propene, treat it with HBr. The negative part of the reagent goes to that carbon which has least number of hydrogen. So 2-bromopropane is the major product. This is called Markovnikov's rule. So the negative part of the reagent goes to that carbon which has least number of hydrogen, and this is called Markovnikov's rule, Markovnikov's addition. But if we don't, if we treat this molecule with propene with HBr in presence of peroxide, then 1-bromopropane, this is major.
It is
here.
anti-Markovnikov rule.
That is called anti-Markovnikov's rule. So here CH3, CH2, CH2 PR will be formed. Only it happens in case of HBr, not in case of HCl or HI. So 1-bromopropane is the major product. This is called anti-Markovnikov's rule. Markovnikov's rule or peroxide effect or Kharash effect. Kharash effect. Note down. So only in case of HBr, anti-Markovnikov's rule happen when we take in presence of peroxide. In case of HCl, HI, there is no peroxide effect because HCl bond strength is very high, and HI, the iodine free radical combines itself to form iodine.
Copy it, sir.
So let me discuss the mechanism of Markovnikov's rule. This also you can write, this also, Markovnikov's also you write. It's a Russian chemist. So CH3, CH double bond CH2 treated with HBr. So what happens? H plus attacks. So it forms CH3, CH2, CH2 plus Br minus CH3, CH, CH3 plus. This is 2-degree carbocation. 2-degree carbocation, and this is 1-degree carbocation. So this pi electron can shift this direction or it can shift this direction. If it shifted this direction, then it will form 1-degree carbocation. If this happens, then this. If this happens, then this. So 2-degree carbocation, 3-degree carbocation is more stable than 2-degree, 2-degree is more stable than 1-degree, 1-degree is more stable than methyl carbocation. So the more stable the carbocation, the easily it is formed. So now bromine will attack this and it will form 2-bromo. Bromopropane. So it will form 2-bromopropane. This will form 1-bromopropane. So 1-bromopropane will be minor product, but this is major. So in Markovnikov's 2-bromopropane secondary carbocation group, it is the major product.
Noted.
Discuss anti-Markovnikov's rule. Also called peroxide effect, because this reaction happens in presence of peroxide, and this is free radical reaction or Kharash effect. presence of a peroxide is mandatory. So in the presence of peroxide, CH3, CH, double bond CH2, treat HBr, take benzoyl peroxide, C6H5CO, C6. Here will be one more oxygen. So you can write shortcut form also. CO hold to CO2. So this will form CH3, CH2, CH2Br. This is called 1-bromopropane and this is the major product. Now we will discuss the mechanism, how this mechanism happens. So it happens by free radical mechanism, free radical chain mechanism. So C6H5, in the first step, this peroxide undergo homolysis. So you know homolysis generates free radical. So here half arrow, here it will be generating a free radical. So this generates a benzoyl free radical. 2 moles of benzoyl free radical will be generated. Now this free radical is not the effective free radical. It will undergo another free radical formation. So it will form 2 phenyl free radical plus 2 moles of CO2. So this is the effective free radical, that is the phenyl free radical. What happens? This phenyl free radical reacts with HBr to form benzene plus bromine free radical. Now this bromine free radical actually attacks propene to form CH3CH2 free radical. This is called 2-bromopropyl free radical and this is 1-bromopropyl free, and this is 1 degree free radical, this is 2 degree free radical. So in this case 2 degree free radical is more stable. So this is less stable, this is more stable. They will react. So this 2 degree free radical with a bromine substituent and one position will react with HBr, that will undergo homolysis. So hydrogen will go with this, so it will become CH3, CH2, CH2Br, and another free radical bromine will be generated, which will be carrying out the reaction further. So 1-bromopropane is the major product. So this is anti-Markovnikov oxidation. HCl and HI will not show peroxide effect. So in case of HCl and HBr, peroxide effect will not be observed. It will not show peroxide effect. So in presence of HCl, even if you have peroxide, HCl, HI will not show that. HCl, the bond energy is 430.5 kilojoule per mole, which is very high. And in case of HI, it is very less, 296.8 kilojoule per mole. Iodine free radical formed combined with iodine free radical to form iodine instead of combining with the propene molecules. So that's the reason. I hope you understood.
Yes, sir.
Addition of sulfuric acid, addition of sulfuric acid. So when ethene reacts with sulfuric acid, it forms ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Similarly, propene will react with H2SO4 to form propyl hydrogen sulfate. Propyl hydrogen sulfate. Addition of water. So keep in mind that in presence of few drops of sulfuric acid, concentrated alkenes react according to Markovnikov's rule to form alcohol. So 2-methyl propene react with water in presence of a little amount of formed H2SO4. So when we write H plus, that means it is in presence of acid. So the methyl group comes at the 2 position. So the negative part of the reagent goes to that carbon which has this number of hydrogen. So this carbon has no hydrogen. So there it will attach. So it will form 2-methyl propane 2-ol or tertiary butanol, tertiary butyl alcohol. So this is according to Markovnikov's rule addition. Okay.
Yes, sir.
Now keep in mind that when you take ethene and treat it with KMnO4 dilute, so dilute KMnO4 1% is called Bayer's reagent. So it forms ethylene glycol, which is an antifreeze compound. Ethylene glycol is an antifreeze compound. Ethylene glycol is also called ethane 1,2-diol. Ethane 1,2-diol. They are dihydric alcohol because it has 2 OH group. It is an antifreeze compound. What is an antifreeze compound? Which is added to car radiator to lower the
Temperature.
freezing point, so that in a sub-zero temperature you can ride your vehicle. It will not, the water will there in the radiator will not form ice. If you take propene in this reaction with Bayer's reagent, dilute KMnO4, potassium permanganate, it will form propane 1,2-diol. Propane 2-diol. Keep in mind that when you have 2 OH group, remove the E, you write full complete alkane and then write diol. If you treat 2-methyl propene in acidic KMnO4, it can form ketones or acid depending upon the nature of the alkene and the experimental conditions. So it will form ketone. So acetone is formed along with removal of carbon dioxide and water. So it forms propanone. But if you take butene, it will form carboxylic acid. Same reagent, it will form 2 moles of acetic acid. So cleavage happens from here. Happens here, this get oxidized to carbon, get oxidized to carbon dioxide as well as water, and this will form a CO, that is ketonic group. This is ethanoic acid, 2 moles. Second last reaction is very, very important. This is called ozonolysis, one of the most important reaction. It is able to predict the position of the double bond. So trick I am giving you, ozonolysis. First treated with ozone, it forms ozonide. This ozonide is cleaved in presence of zinc water. So it breaks like this. So aldehyde ketones or both can be formed depending upon the nature of the alkene. So keep in mind that if you have suppose this compound, This is called butene. If you are treating with ozone and doing with zinc and water, treating with zinc water. So what you need to do is just clip from here and put oxygen. So this is also ethanol. This is also ethanol. So 2 moles of ethanol are formed from butene. So this is the trick. If they give you the product, if they give you the product, just bring both the carbon oxygen double bond, carbon oxygen double bond, remove both the oxygen and join with carbon carbon double bond to get the parent alkene from which that product has been formed. Suppose you have this alkene. So if they ask you what is the ozonolysis product, then what you need to do, just clip from here. This will become acetone. First is acetone and second will become CH3CHO. So it will become aldehyde. So one is propanone, another is ethanol, propanone, ethanol. So both aldehydes and ketone can be formed depending upon aldehyde. Sometimes both aldehyde, both ketone or aldehyde ketone can be formed. So this is ozonolysis. It is useful in detecting the position of double bond in alkenes and other unsaturated compounds. Very, very important. So it is, the reaction is highly useful in detecting the position of the double bond in alkenes and other unsaturated compounds. Very, very important reaction. Definite question in entrance exam, definite question in 11th board. Last reaction we are going to see polymerization. So ethene undergo polymerization reaction, high temperature, high pressure. So it forms polythene. Just put single bond, put
We
both
use
side
this
bond
in
and
batch.
put. This is called polythene. So this type of reaction is called Homo Polymerization. This is example of addition polymerization. Polymers are very, very useful. The process of formation of polymers from monomer is called polymerization. This is ethene, the monomer. This is polythene, the polymer. Very, very important. So thanks for watching, student, this video. This is very, very important.